So we recall that the power series is f of x is equal to c sub 0 plus c sub 1 times x minus a plus c sub 2 times x minus a squared plus all the way to c sub n x minus a to the n. And if we let x is equal to a, f of a then calculates to be c sub 0. All the other terms cancel out. And then if we look at the derivative f prime of x, that'll get c sub 1 plus 2 c sub 2x minus a plus 3 c sub 3x minus a squared all the way to the n c sub n x minus a to the n minus 1. And then f prime of a calculates just to c sub 1. Then the second derivative, which is 2c sub 2 plus 2 times 3c sub 3x minus a plus 3 times 4c sub 4x minus a to the second plus all the way to n minus 1 times n c sub n x minus a to the n minus 1. And then substituting in the value of a, the second derivative at a is 2c sub 2. And then getting the third derivative, get 2 times 3 c sub 3 plus 2 times 3 times 4 c sub 4 times x minus a all the way to n minus 2 times n minus 1 n c sub n x minus a to the n minus 3. So then the third derivative at a is just 2 times 3 times c sub 3. And then notice that that is really 3 factorial c sub 3. And so what's the pattern? Well, the nth derivative of f at a is equal to n factorial c sub n. And by solving for c sub n, we get the nth derivative of f at a over n factorial is c sub n. And c sub n is the nth coefficient for f of x. So the power series, which is f of x is equal to c sub 0 plus c sub 1 x minus a all the way to c sub n x minus a to the n, where then the c sub n coefficient is the nth derivative of f at a over n factorial, and that's equal to c sub n. So then to write out the Taylor series, f of x is equal to f of a plus the first derivative of f at a times x minus a plus the second derivative of f at a over 2 factorial times x minus a to the second. And that keeps going until you get to the nth derivative of f at a over n factorial times x minus a to the nth. So replacing the c sub n with that formula of the nth derivative of f at a over n factorial. So that's the summation of k equals 0 to infinity of f, the kth derivative of f at a over k factorial times x minus a to the kth. And so this is the Taylor series where f is generated at x is equal to a. And then if you look at the partial sum, so only adding up n number of terms, so Pn of x, that's the partial sum, is f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a to the second. And that's adding all the way up until only the nth term. So that's the nth derivative of f at a, x to the n over n factorial, and not going to infinity, but just going until n. So it's a summation of k is equal to 0 just to n of the nth derivative of f at a over k factorial times x minus a to the k. And this partial sum is called the Taylor polynomial of order n for that function f of x at x is equal to a. And then we have the Maclaurin series with the mathematician Maclaurin, who devised the Taylor series to be generated at x is equal to 0. So that's f of 0 plus f prime of 0 of x plus f double prime of 0 over 2 factorial x squared plus f triple prime of 0 over 3 factorial x cubed, which is the nth derivative of f of 0 over n factorial x to the n. So the Maclaurin series, which is the Taylor series, just generated at x is equal to 0.